He went to get his logbook, his booklet. All right, guys. So we are working on this last part of algebra for the linear stuff that we've been learning about for the past 2 weeks. Like I said, a lot of this won't make sense if you don't actually do the work. Yeah, if you don't understand bits and pieces before this, then this is not going to make sense. So you need to make sure you go back, actually redo those questions or rewatch the videos. They're all there. There's only really two concepts that I taught you. Well, we could say three for the previous chapter, which was how do we draw the equation, the line of the equation, yeah? But this time around, it's going to be the other way around. It's going to be how do we find the equation of the line? So if the line's drawn for us, how do you get the equation from that? Okay, that's the aim for this session. So you'll understand the what the equations look like. Actually, can anyone tell me what does the equation look like? It's got the y in it. It's got an mx and a c. What does it look like? Tell me. Mx plus c. Yeah, that's what the equation looks like. And we know that x and y are like the points on a graph. M is the gradient, and c is the y-intercept. That's what that all is. I'll explain that as I go. But as our learning intention today, I want you to be able to find an equation of using any 2 points on a graph. Remember, when we're drawing graphs or lines on a graph, you only need 2 dots or 2 points. It's the same when you're looking for an equation. You only need 2 points. Okay. So what you need to be able to do is you need to find the gradient using 2 points. You need to find the y-intercept, okay, using those 2 points if need be, and calculate the y-intercept if you have the 2 points and find the equation, which is, again, remember the equation looks like this: y equals mx plus c. All right, and if I was to color code this, yeah, I could. The gradient, remember, is the m. The y-intercept, okay, remember, is the c. Okay, that's what that is. So those are two things you're looking for: gradient and y-intercept in any line. Okay, two things. Right, quick recap. We know that the equation, and you guys already talked about it, of any line is generally just y equals mx plus c. So x and y are the points, whatever they might be. So these guys change, but what you're looking for is the gradient and the y-intercept. I kind of spoke on this, but what these are those graphs with the either horizontal line or just a vertical line. So, for example, with a y equals graph, you're going to have a graph that looks like this. Okay, and it might look like that. And the point there might be 5. So, Attila, if I ask you, what would the equation of this line be? It'd be y equals what? 5, that's it. Because it's just a horizontal line. Y equals 5. Okay, what if the line looked like this? Let me make another one. Say you had an equation there. Oh, there's your lines. And your line went this way. And the point right there is -4. So, Lizzie, what would this equation be? X equals what? This one here. What would this equation for that line be? X equals? Have a think. Where does it hit the line on the x-axis? No, look. Where does it hit it? I've labeled it for you right there. -4. So it's x equals -4. That's the equation there, yeah? And obviously for our generic ones, like if you have a graph for the y equals mx plus c equation, right? So let's draw that. Okay, the graph might look something like, and this might just be like a rough drawing, but it might be like this. And the y-intercept there is like 2. So I'm going to make up an equation. It could be y equals negative 2x. Let's go negative 0.5x plus 2. Okay, that implies, right, that the gradient is going down and the y-intercept is 2. Okay, so that's what our formulas are. Now, what we're going to look for, okay, this went blank all of a sudden, is we're going to look for the equations now, yeah? That's the aim for this one. Why did it disappear? Alright, sorry guys. Alright, so that's the aim for today. You're going to look for the equation, the y equals mx plus c equation. All right, so let's do that. All right. All right, here we go. So, first one. Let's go through some really basic ones. Starter activities. So let's go to this page. You should be up to this slide with me. We're going to try and find the equations for these. Yeah, and I kind of went through it with you already before. Let's go with Krish. Can you tell me what is the formula for this line here? Can you tell me what's that formula going to be? Y equals? Oh, well, no, not quite. Y equals what? Where does it hit the y-axis? 2. So it's just y equals 2. You get it? Let me ask you this, Krish. What would this one be? No. X equals -3. Watch where it hits the axis. Okay, so if it's a y line, it's going to go like that. So it's y equals. If it's an x line, it's going to go vertical like that. So it's that. X equals. A couple more, all right, just to make sure we all understand it. Let's go with Chris G. There's my line. Let's say that this is... All right, let's go here. Let's say that this is -2. So what's the equation there? Don't tell him, Attila. -2. Easy, man. Okay, nice and easy. If it was a vertical line, like, let's make another one. Like there, and that was like 10. What would this be? Sienna. X equals 10. There you go. Not hard, yeah? Those are the two equations, okay, that we can figure out easily, the X and Y lines. Okay, now, how does this relate then to lines that have gradients and Y equals mx plus c? So you need to be able to find the gradient and the y-intercept for this. But for now, let's do it one at a time. Well, let's look for the gradient. So for any equation, okay, you need to be able to calculate the gradient of the line. So remember, your equation looks like this. Okay, you need to look for this guy, the m. That's the gradient. That's one thing you're looking for, and the other thing you're looking for is the c for the y-intercept. But for now, it's just the gradient. It's really easy, yeah? When you have the gradient, all you have to do is find the rise over run. You guys are very familiar with this already. You know how to find two dots, one with the y-intercept and one with the gradient. Here, once you know the rise over run, it's pretty much just whatever the rise is. So in this case, it's 6. And then whatever the run is, which in this case is 4. So therefore, what's the gradient, Attila? Simplify that for me. 2 over 3, yeah? 6 divided by 4. Oh, sorry, 3 over 2. 3 over 2 or 1.5. So that's the gradient. So therefore, if you're trying to look for the actual formula of y equals mx plus c, the gradient would be y equals 1.5x plus whatever c is going to be. Okay, so that's the first step. Just use your rise over run. And what you can do is you can actually, on the graph, you can pick any 2 points there to do this. So let's say my point was, well, they use these points here, these 2 points. So according to this, the run would be 2, 3, 4, 5, 6. So that's 4 spots to the right. And then from here be 3, 4, 5, 6, 7, 8, 9. Right, 6 spaces up. So the rise of a run, 6 over 4. We'll work on it together in a second, but does this make sense so far? Just rise over run, that's it. That's all you're using for that one. Any questions? Abby, you got any questions? No? Okay. The second way we find the gradient, so there's 2 ways of finding it. I find that doing this one is probably the easier way. You just need to remember the formula in your books. Now, I don't know if you guys have ever done this before, but there's this formula we call y2 minus y1 over x2 minus x1. All you have to do for this is you need to look for 2 points on the line, any 2 points. So when we say 2 points, I mean 2 coordinates. So in this case, they're using -4, 4, and then 2, 1. Okay, so we're using 2 points. So all you got to do, using that formula, y2 minus y1, x2 minus x1. What I like to do, on your sheet, if you can, label these points x1, y1, and then x2, y2. It actually doesn't matter. Good. doesn't matter whether you do that or you go the other way. You can go x2, y2, x1, y1. It's the same thing, yeah? But as long as you label them, and this will help you. So let's just call it x1, y1, x2, y2. And then what we do is using that formula, you just need to change y2, y1, x2, x1 to whatever it is here. So let's change that. So this is going to be y2 is 1, take away y1, which is 4, divided by x2, which is 2, take away x1. Now watch out for that. It's minus negative 4. Okay, what do you guys think will happen when you have two negatives next to each other? It has to become a positive. But if you put it in your calculator, it'll do it for you anyway. So I'll just leave that there so we know. Okay, so the gradient here is going to be calculated. If you can literally type that in your calculator. All right, so you're going to go 1 take away 4 divided by 2 take away negative 4 equals negative a half. So there's your gradient. Right, so if you were to put that in your formula, y equals mx plus c, Karan, what would my gradient be here that I'm going to change m to? Negative a half. So it's just going to be y equals negative a half x plus c. Okay, that's the first thing you got to do. Find the gradient. Does that make sense? Maybe I'll do one more example. Yeah? Let's do one more just to understand the whole the points. Let's make up, I'm going to make up any 2 points. Maybe do this in the top right corner there. Let's go with 0, 2, and then negative 2, 5. I don't know if that one makes sense. 0, 2, 2, 5. Yeah, okay. Yeah, we'll go with that. All right, so let's go with this as my 2 points. So what you're going to do is label it. x1, y1, x2, y2. Remember the formula. y2 minus y1 divided by x2 minus x1. Okay, so in this case, it's going to be 5 take away 2 divided by negative 2 take away 0. So the gradient for this should be 3 over negative 2, which is negative 1.5. Okay, so same deal, yeah? You're just going to use your calculator for this if you're confused. But use that formula to find your points. So you need only 2 points, and then find your gradient using that formula. Did I go too quick? Okay, can I go to the next one? We'll move on. It's not too hard, yeah? All right, so let's do this one as an example. This one's easy. So we need to find the actual equation. Remember your equation is, let's see. Van, what's my equation? It's going to look like this. Y equals what? Y equals, what's the letters that we're using? mx plus c. So you're looking for the gradient and you're looking for the y-intercept. Those are 2 things you've got to find. So according to this, we need to find the gradient and then find the y-intercept. So let's do that. Question A, find my gradient. All right, here's a trick question, yeah? It's a bit tricky. I need to find 2 points. What 2 points can I use here? I've seen one already. Yes, Donnie. 1. What do you mean 1? 1 and 0. What coordinate is that, though? Give me the coordinate. 0, 1. Good, because it's a y-intercept. So there you go. There's your 2 points. So all you do now is, let's call this x1, y1, x2, y2. Remember the gradient formula. Okay, or you can say m. Okay, which is the gradient, is y2 minus y1 divided by x2 minus x1. Okay, just put that in. So y2, Abby, what's y2 here? What's y2? Good. What's y1? 7. So it's 1 minus 7 over x2, which is 0, take away x1, which is 3. Okay, so just looking at, yes.
On the graph, it already labels.
The y-intercept?
It says that 7 is y2.
Oh, there's a dwarf. Okay. It actually doesn't matter which one's which, because if you do this, it'll give you exactly the same answer anyway. So whether, like I mentioned, yeah, even if you make this x1, y1. Oh, sorry, did you say 7 was x2? So if you do x1, y1, x2, y2, or the other way around, it still gives you the same answer. It's exactly the same thing. Okay? It doesn't really matter. But yeah, I'll fix it up so it doesn't confuse anybody. X1, y1, x2. Okay. All right, so putting that in, we're going to go 1 minus 7, which is negative 6 over negative 3. And then that will equal to, if you use your calculator, again, if you're confused about this, put it all in your calculator. 1 take away 7 over 0 take away 3. And it should be 2. Okay, so the gradient will be 2. Regardless, even if you did it the other way around here, you should still get the gradient of 2. So in my formula, m should be 2. Okay, next question is part B. We're looking for the y-intercept. That's really easy because it's already there. It's already told us what it is. All right, Sam, what's the y-intercept in this graph? 1. So the y-intercept is 1. So when we write the rule, okay, so for part C, when you write the rule, okay, it's going to be y equals, remember the rule is y equals mx plus c. You're only changing two things. Change the gradient, change the y-intercept. So Steph, what's my gradient here? Y equals what so far? 2. So y equals 2x. And Sienna, what's my y-intercept according to this? 1. So it's just going to be y equals 2x plus 1. There's your rule. That's it. Remember, your rule has to look like this. Okay, it has to. Any questions? No questions. All right. Let's do one more example, and then I'm going to let you guys work. All right, cool. Karan, did you have a question? Oh, okay. All right. Let's do one more example, because now in this graph, you can see that you don't know what the y-intercept is. Okay? Here, Donnie, do you know where this hits the y? Possibly. We don't know exactly. Hard to say. So we need to know exactly what that point's going to be. So for the graph, find the gradient, find the y-intercept, and then write the rule. Okay, so really, really easy. All right, so what you're going to do here is for the graph, actually for the first thing we need to do is remember your equation has to look like this. And you're looking for the gradient and the y-intercept, two numbers. All right, firstly, let's find the gradient. So what's the first step, guys? Tell me what to do. What am I going to do with these points? Label them, yeah? And you can label them any way you want. You can go x1, y1, x2, y2, or you can go the other way. What you don't want to do, though, and please do not do this, don't go x1, x2. Do not do that. Okay? That's incorrect. It has to be, if you call this x1, you must label this one y1. If you call this x2, you must call this one y2. Or vice versa. If you've called this x2, you have to call this guy y2. And that's x1, y1. Regardless of whichever order you do it, it's going to give you the same answer. All right. So the first one we have to do is find the gradient. So let's do that. The gradient m is going to be y2 take away y1 divided by x2 minus x1. So y2 here is 2. Y1 is, y2 is 7, my bad. Y1 is 2. X2 is 4, and then X1 is 8. Okay, so when we do that, actually before I even give you the answer, is the gradient going to be positive or negative? Negative. Good, because the line goes down, yeah? So that's how you can confirm if you did this correctly as well. So this should be 5 over negative 4. Or if you want it as a decimal, it should be negative 1.25. But this is also fine, yeah? You can leave it as a fraction. That's the first one. Now, in my equation, this is what you have so far. It's going to be y equals negative 5 over 4x plus c. So this is for part B. This is my equation so far. What it's asking us to do is substitute one of the coordinates into y equals mx plus c to figure out what that y-intercept is. Okay? Oops. Okay, because we need to figure out what is c. So all you have to do, guys, this is actually not hard, is just get one of your points, okay, x or y, or x1, y1, or x2, y2, and you just got to put it in here to find out what c is. So when we talk about substituting, all you're doing is you're changing x and y to whatever x and y is going to be here. So let's see. Elliot, can you pick one coordinate for me that we're going to use out of here? Which one of these two should we use? 4, 7, all right? So we're going to use 4, 7. All right, so the coordinate is 4, 7. All right, that's x, that's y. All I'm going to do is change x and y to the x and y here. So in this case, y is 7 equals negative 5 over 4 times, what's my x? 4, okay, plus c. And you guys have done this before. Now you just have to, all you got to do is solve the equation. Okay, so 7 equals, if you're confused about this, use your calculator. So negative 5 over 4 times 4. So negative 5, actually. Okay, use your calculator. 5 over 4 times by 4 equals negative 5. So it's negative 5 plus c. What's the next step from here, guys? You've seen these before. What do I do next? Well, not quite substitute. Sorry, say it again. Yeah, algebra. What do I do? I'm trying to solve for c here. What am I doing? Oh no, I don't have to do. Don't go that far. I'm just moving one number. Have a think. What number can I move? Negative 5. Yeah. So Steph, when I move negative 5 here, it becomes positive 5. Yeah. So when you move this negative 5, it becomes 7 plus 5 equals c. So what does c equal? 12. That's it. There's your y-intercept, 12. Now, Donnie said he was 8. Not quite. Yeah, it's 12. So we need to be exact about it. So when you write your full rule, it is a lot. Okay, but we'll do one more. So yc. The equation is y equals mx plus c. We know that the gradient was negative 5 over 4x. And my gradient is going to be 12. So plus 12. So there's my full rule. Okay, that's the full entire rule for that equation. Can we do one more together in your books, your workbooks? I think we should do one more just to get you started. Yeah, let's do one more. I'll do, so you don't have to do this question again. I'll do one of the questions there for you. Okay, so let's do, pick one of these. We'll do it together. Any one of them. C? Let's do C. Okay, let's do C together. So if you want to do this in your books, or if you want to do it in your bound reference, it is very good to have one of these as an example. And then that should be it for this session. Okay, so let's do that question. Okay, let's do C. Okay, so remember, you can copy out the way that I write it, but remember for any question like this, when we need to find the formula, copy this in your books or in your bound references. Okay? Yeah, come get it. All right, so again, with these sorts of questions, you only need to have 2 points. I can see there's 2 points there already. And also, our formula needs to look like this. Y equals mx plus c. So you're looking for 2 things. You're looking for the gradient, and you're looking for the y-intercept. 2 numbers. Okay, not hard. So firstly, let's start with the gradient. Let's see. Kira, can you tell me what's the first step for this? What are we doing with these 2 points? we should label them. Yeah, what are the labels that we have for them? X1, Y1, and X2, Y2. So I might go X1, Y1, X2, Y2. Okay, let's call them that. That's the first step. Come on, OneNote. What are you doing to me? Alright, sorry guys. X1, Y1, X2, Y2. Those 2 points are what we're working with. Okay. Now remember, for the gradient formula, can anyone tell me what's the formula? M equals what? Y2 minus Y1 divided by X2 minus X1. Alright, so now we replace the numbers with the letters. Okay, so draw. Alright, so we're going to do Y2, which is negative 7. Take away Y1, which is negative 5. Over X2, which is negative 3. Take away X1, which is negative 1. There's a lot of negatives there, yeah? But if you put it in your calculator, it should do it for you anyway. Okay, so when you put this in your calc, negative 7 take away negative 5 over negative 3 take away negative 1. And that gives us 1. Lovely. So the gradient so far is 1. Okay, so for M, it's going to be 1. Easy. The next thing is, so far, for my equation, it's going to look like this. So we need to find the y-intercept. So your equation so far is going to be y equals 1x plus c. Okay, what we need to do is pick any of these points, doesn't matter which one, and put them into our equation. So Lizzie, can you pick a point for me that we can use? Negative 3, negative 7. All right, let's use this one here. So all you got to do, okay, so your points are, oh my gosh, I am doing C. I'm so sorry, guys. I don't know what is wrong with OneNote. Why does it keep doing this? It's so annoying. Ugh. Okay, very, very sorry, guys. This is very laggy today. All right. So we're going to use the point that Lizzie mentioned, which was negative 3, negative 7. So just write that point in here, negative 3, negative 7, and you know that that's x, that's y. So you just need to change x, y into here, whatever x, y is. So, Chris, what's y? Look at my points. I need to change x and y into x and y here. So what's my x and y? What's my y? Start with that. Negative 7 equals, okay, 1 times, Attila, what's my x? Negative 3. And then plus c. So what you're going to do here is solve for c because we're trying to find the y-intercept. So this will be negative 7 equals 1 times negative 3. If you're confused about that, it should be negative 3 and then plus c. Okay, and then solving from that, what's the next step, guys? Yes, Alana.
Plus 3 to negative 3.
Good. Plus 3 to negative 3 to get rid of it, and you do it over here too. So it becomes plus 3. So I'm going to rewrite it. It's going to look like this, yeah? Negative 7 plus 3 equals c. So what does c equal? If you don't know, it should be negative 4. Okay, just use your calc if you're not comfortable with your actual formulas. Negative 4. So last step, what's the actual equation? It should be y equals, what's my gradient, guys? What's my gradient? It's right there. 1x. And then what's my y-intercept? Negative 4. So that's my equation. Y equals 1x minus 4. It's a lot of work, yeah, but a question like this will yield you a lot of marks in the SAC. So make sure you get good at it. All right, I'm going to stop there.